what you see here, this is from 1950 to 2050, is that increased number of elderly people relative to the number of working people. So working people are going to have to be much more productive to maintain the way we operate. Japan has it worse than we do. Korea has it worse than we do. We have immigration, which helps things not be quite so bad for us, but China also has it badly. So it's going to affect the whole world. And in manufacturing, one of the major cost is labor cost. But look at the cost of labor here. U.S. it's about $30 an hour. In China, it's about 90 cents per hour. These are numbers put together from a number of different sources referenced down the bottom, but 2006 roughly. That explains why industry has outsourced to places like Mexico and China when they can, when the cost of labor is so much lower. But that's not the whole story. It's much more complex than that. U.S. manufacturing productivity has increased faster than other productivity in the U.S. This is the ratio of the relative productivity in manufacturing and non-manufacturing business in the U.S. since 1950. You see, U.S. manufacturing productivity has done well. It's increased at roughly 3.7% per year with pretty much flat employment in the U.S. over a 60-year period. That's pretty good. So U.S. productivity has been good. In fact, U.S. manufacturing, number was given 11%, it's still about 3 times the size of Chinese manufacturing. We tend to forget that. U.S. manufacturing is still a very strong industry. And value added, the manufacturing gives is the world's largest, and that's growing slowly. So what are we going to do to maintain our manufacturing, not have things follow the cheap labor, and keep the U.S. strong? Well, I think we need American manufacturing to be both smart and productive. We have skilled workers. We need skilled workers who go after both high value and mass market products. Time magazine this week talks about high value products, but I think we should also be trying to go after mass market products. When you look at supply chains from China, where they're 26, 28 weeks long, it doesn't match with what retailers, how responsive retailers want to be to our needs. And so we need to reduce that supply chain, and oil prices will go back up again, and the cost of transport across the ocean was becoming significant last summer. It was having a big impact as the cost of oil went up, and it will go back up again. So, in my view, we want to make robots take over the simple cases of simple tasks, freeing workers to be smart as we educate our workers better. And this gets back to robotics being a key part of STEM. There can be a good cycle here where robotics encourages students to learn, and as students learn, they get to be better workers and get to be more productive. I also like to look at this a slightly different way, and that is in terms of the Industrial Revolution. In the late 18th century, the first wave of the Industrial Revolution used external energy sources to replace muscle energy. Before that, everything was done by hand. And we had steam engines, and we had mechanical distribution of energy to workstations where individual workers worked. That was done in the UK. Around 1900, large-scale electrification happens. You no longer had to have mechanical coupling from the steam engine to where the workers were, so you could redistribute where work was done. That was led in the US. Now I think that the next wave of that revolution is between the worker's hands and brain, put computational intelligence between them and the workpiece, so they're working smarter. Question is the USA going to lead this, or is it going to be Korea, or Japan, or China? And I, of course, want it to be the US. US led the world in industrial robotics. The first industrial robot was the Unimate. Joe Engelberger, still alive, led that effort in the 50s. First installed in the General Motors factory, we remember them, in 1961. And that was later, though, the company was later bought by Westinghouse and then sold to Kawasaki. It's that company went to Japan. When those robots were first built, computers were, things that filled a room this size. So there was no computer to control these robots. No sensors. Sensors were very expensive. The robots did the same motions repetitively, again and again. And the cost of systems integration was about 10 times the capital cost of the robot. And that's, to a large extent, although we see Adept here and other people who are trying to tackle this, that's to a large extent what happens with industrial robots today. They're doing the same mindless operation again, they're very hard to program, high cost of integration. They haven't really yet exploited the microprocessor and network revolution. It hasn't gone into industrial robots. That's where the real opportunity right now. So today's manufacturing robots are unsafe for people to be around because they have no sensing, they're big and they're stiff and they're trying to get accurately to places. They're engineered to be precise and repeatable, not to be adaptable. They only operate in very structured environments. You've got to spend a lot of money getting the environment ready for them, and their application is limited. And that's why we have outsourced a lot of our labor for mass market products to what you might call robots, as in workers, low-cost workers, who are doing very simple operations again and again without any real intellectual input into the endeavor. Very unlike what you see in an American factory, where there's much more intellectual input from the American workers. Oh, great. So, back in the old days, ordinary people couldn't touch computers. Now they can. That has completely changed the productivity of American workers and the sorts of things they can do. And so, what if American workers could touch the robots and interact with them? And in fact, now they can. We've seen healthcare, we've seen home robots, and military is leading the way. There are lots and lots of soldiers in Iraq and Afghanistan using robots today.